Okay, we're going to work with the chapter 6, factoring. So let's look at the board. All right, so chapter 6, we're factoring. So we need chapter 6 to do chapter 7. So it will be very important that you master how to factor, whether you're dealing with factoring out the GCF, factoring by grouping, or factoring a trinomials, or even combinations. All right, so the first thing when you're factoring, you want to always look for the GCF, okay? So whenever you're factoring, you look for the GCF first to pull out, okay? Once you look for the GCF, if there is one, pull it out, and whatever's left, you determine whether you can factor some more. It depends on what type of polynomial you're dealing with. You may have to factor by grouping. It may be a trinomial where you can factor into 2 binomials, or maybe a special pattern. So basically, we'll start with the GCF, okay? Then we'll look at factoring by grouping. And then we'll look at the trinomial 1 pattern. And then we'll get into the trinomial 2. And that's where A is not equal to 1, okay? And I'll show you a special method for factoring trinomials too. All right, so let's look. Let's start by the GCF. So let's go to the math program. And so for your homework set, there are 39 problems, but it's just to give you plenty of practice. It starts off by finding the greatest common factor. And so let's look at this. The question is, what is the greatest common factor? All right, so the greatest common factor is the greatest number that will go into both of your terms. Okay, so if I'm dealing with 24y and 40, now you can also use the tree method. Okay, so if you use the tree method, you can find all the factors of 24. We know that y is part of it, but this doesn't have a y, so we know that's not in common. So break 24 down, so we can start off with 3 times 8. Okay, and 3 is prime, so let's circle that. 8 is not, break it down. 2 times 4. 2 is prime, but 4 is not, break it down. And so that's 2 times 2, right? And so we have our prime factorization of 24. And I like to do it in order. So we got 3 2s and a 3. And we'll just bring down the y since it's part of it. And then 40, break down to 40. Okay, so what 2 numbers multiply to give you 40? And remember, it doesn't matter what 2 numbers you start with. Okay, you end up with the same prime factorization. So we can start off with 4 times 10 if we want to. Okay, or 2 times 20. All right, so 4 is not prime, so it can be breaking down. 2 times 2, 2 is prime. Break down the 10, 2 times 5, 2 is prime, 5 is prime. Okay, so now the prime factorization of 40, we got 3 2s and a 5. So when we look for the greatest common factor, you look and see what they have in common. So what do they have in common? They have 3 2s. 3 2s in common, and that's it. So the GCF is 2 times 2 times 2, and then you multiply that out, that gives you 8. So that's your GCF. All right, good. All right, so now when we're looking at this, some of you can look at, okay? Now when dealing with the variables, okay, that's probably easier because we can see that they all have an x in common, but they all have an exponent, okay? So basically, it's saying what do they have in common? So in common, they have 5x's because that's the lowest one, okay? So 5x's. So here, and just to, so it's like you're writing 5x's out, okay? So 1, 2, 3, 4, 5 for the first group, and then you have 7 in the other group, and then you have 9 in the third group. And so you're saying, what do they have in common? Well, they have 5x's in common. So that's only, it's in terms of the variables, okay? So they have 5x's in common. So that's x to the 5th. Okay, so we can look at the variable part. The GCF for the variable is x to the 5th. Now we have 70, 30, and 60, okay? So basically we have to find out what is the greatest common factor of 30, 60, and 70, okay? And so we can look and see that 10 will go into each of them, okay? Now the question is, will anything else higher than 10 go into them, okay? And again, if you're not sure, all right, basically you can do the tree factorization to be sure. This is 10 times 7. We can break the 10 to 2 times 5. That's prime, that's prime, that's prime. So we're looking at 2, 5, and 7. 30, we can start off with 3 times 10. 3 is prime. 10 is 2 times 5, and they're prime. So you're looking at 2, 3, and 5, and then 60, and we'll do 6 times 10, since we do. Break down the 6, that's 2 times 3. Break down the 10, is 2 times 5, and these are your prime factorization. That here I have 2 2s, a 3, and a 5. So now it's just looking at, we already know that they have x to the 5th in common, okay? So I know that they have x to the 5th in common. So let's circle what they have in common for the number. So they have a 2, a 5, and that is it. Okay, and so therefore, like we said, 10. So the GCF is 10x to the 5th. Good. So now that you've had some practice finding just the GCF of your terms, whether you're dealing with numbers, whether you're dealing with variables or combination, this is how you work it. So now we're getting ready to get into the process of factoring out the GCF. All right, so they give you plenty of practice with the factoring, looking for the GCF. Now they're getting you started, okay? So pretty much here, if we look at this, we're trying to fill in the blank. So this takes us back to chapter 5, okay? Almost. So if we have 65, x to the 7th, and we're saying that we're pulling out 5x to the 5th, and it says times what's left. This is the unknown here. Basically, what we're doing here, when we pull out 5x to the 5th, it's like we're dividing, okay? So it's like we're dividing this by the 5x to the 5th, okay? And so when we simplify, this is what we did in chapter 5. You simplify. So it's almost like I'm solving, so I'm dividing, okay? So to find out what's left, I simplify this, okay? And so you do the 65, will 5 go into 65 is the question, okay? So yes. So 5 will go into itself, 1, into 65 13 times. Now notice here you have x to the 7th over x to the 5th. This goes back to chapter 5, dealing with your laws of your exponents. When you're dividing like bases, you subtract. All right, so we have the question mark, okay, will be 13 then x squared, okay? And then as a check, if you did 5x to the 5th times 13x squared, well, 5 times 13 is 65, and x to the 5th times x to the 2nd is x to the 7th. So that works out. So that's what they're getting you in shape for factoring by pulling out the GCF. All right, so let's look at, and you can pull out a negative. So let's go into an actual problem, okay? Here, so if we have something like this, and they pretty much help you get started. So if we have the problem, 5y plus 30, and we have the factor by finding the GCF. So what do they have in common? What is the GCF? Okay, good. So the GCF is 5. Okay, I'm going to factor out the 5. So in essence, we're going to pull it out. So if we pull it out, put it on the outside, we got to see what's left on the inside. So when I'm pulling out the GCF, in essence, I am dividing each one by 5 to see what's left from those terms. So now to simplify, you're left with y plus 6. You see that? And this is your factorization of 5y plus 30. And that's nothing else I can do with this expression inside. So this is it. Okay. All right. All right, so let's look at this one. This is more. All right. Okay, so if we have 20s squared, and that's z, plus 16s 3z to the 6. All right, so let me s squared z. Okay, so we're seeing what do they have in common? What's the GCF? Oops. To the third, z to the 6. So look at the number. So 20 and 16. What's the greatest common factor of 20 and 16? What number will divide into, what's the greatest number, common number, that will divide into 20 and 16? Okay, so 4. Okay, 4. Now, looking at the variables, they have a s and a z in common, right? So we know we're going to put s and z, and then you pick the lower exponent. Okay, so the lower for s is squared, and for z, it's just z. So this is your GCF. That's what they have in common. So we're going to pull that out. So pull out the GCF, so 4s squared z. And that's going to be on the outside. So now we have to write what's left on the inside. So in essence, when I pull that out, I'm dividing out an 4s squared z from each one. Okay? And now simplify. This is what you did in chapter 5. Simplify. Reduce that. So 20 over 4, that's 5. And then the s squareds cancel and the z's cancel. So you just left with 5. Okay? So 5 plus, and then simplify this fraction. So we have 16 over 4, which is 4. And then s cubed over s squared, which is s. And then z to the 5th, because that's 6 minus 1. And this would be your, okay? And so now if you're going back, let me write it down so I can go into the program and write. All right, so let me just go into the program. And so if you put it in here, let's put it in. So we have, what do we say, 5. Yep, 5. And then plus 4 s z, and that's to the 5th. So you have to use your exponent to the 5th. Okay, click out, then check. Good. All right, and so again, all right, so you're dealing with the factor and the greatest common factor. Out here, x squared minus 5x. So what do they have in common? Is there a GCF that we can pull out? So good, they have an x in common. So the GCF is x, okay? So we're gonna pull x out. And what's left? So again, you do your little trick, divide each one by x to see what's left. So simplify, that gives you x minus 5. And this is your factor. X times the quantity of x minus 5. Okay. All right, so now let's look. All right, here we go. This part here, we're getting into the grouping. All right, so when we see this, we'll write this out. So we have what, a squared times 2a plus c minus c, and then in parentheses 2a plus c. So what do you see that they have in common? Good, they have the 2a plus c in common. 2a plus c, this is called a binomial GCF. This is used when you're factoring by grouping, okay? This is the part where you want to get to, okay? So we can get to this, then we only have one step to get to the answer normally, okay? Unless there is more work to do. But here, this is the part we want to get to. So the binomial GCF is 2a plus c. So we're going to pull that out, and it has to be in parentheses, okay? Because it's together. Once we pull out the GCF, then we have another set of parentheses. So what's left, okay? And again, it's just like we're dividing out the 2a plus c, 2a plus c. I mean, they cancel out. I'm left with a squared minus c. And I can't factor a squared minus c because we don't know, you know, c is, it's just c. We don't know what that is. So this is it. Now, does it matter if you write it a squared minus c first and then put 2a plus c second? No, it doesn't. Okay. All right. That's like the commutative property of multiplication. All right, good. All right, so now we're actually going to get into the second part, which is the factoring by grouping. Okay, so we kind of did this one. Okay, factoring by finding the GCF. You had some practice with the numbers and the combination of numbers and letters, and we got set up we had a problem that actually dealt with grouping. You didn't realize it. And it's called a binomial GCF. So we're getting ready to do the factoring by grouping so you can see that. Okay, so now let me show you how it works. When we're factoring by grouping, okay, normally we have more than 3 terms. Here we have 4 terms. Okay, so since we have 4, then we'll have 2 groups. Okay, you always need the same number in each group. So if I have 4 terms, 2 and 2. If I have 6, which you're not going to deal with, you have 3 and 3. All right, so I'm going to factor by grouping. So basically, when you factor by grouping, you do group 1 plus, put your plus sign, plus group 2. All right, and so now you have to determine who's going to go in group 1 and who's going to go in group 2. Now, sometimes there are different combinations that work, okay? And so here, I mean, you might try, you know, you may see, oh, I want to do 7m plus 21 in one group and mn and 3n in another group. And that might work, okay? So the whole objective is when you factor out each group, whatever's left inside, we want them to be the same, okay? So let's do the first 2 and then the second 2. So we'll put 7m plus mn in the first group. And in the second group, we have 21 plus 3n. And so now you already know how to factor by finding the GCF. That's what we're going to do. We're going to do each group. So look at the first group. What do they have in common? They have an m. And that's about it. So pull out the m. And so what do you have left? You have 7 plus n. Okay, so now this is what I want to end up over here when I factor this one. I want to end up with 7 plus n. So looking at here, what do they have in common? 3. Good. So the GCF is 3. Okay, the GCF over here was M. All right, so bring down my plus sign. I'm going to factor out a 3. This is a 3. Factor out 3. And so that's like, again, dividing by 3. So I'm left with 7 plus n. So this looks just like the last problem we were dealing with. So at this point, we can see that they have 7 plus n in common. See, look at the big picture. Okay. So we're going to pull that out. So 7 plus n, and what's left? So m plus 3. This is your factor. Okay. Very good. This is factoring by grouping. The only, I guess, trip up is when you have signs, different signs in there. And we're going to look at one. Okay. I'm going to look at one that has, okay, this is one. All right, so we have 8st plus 12t minus 10s minus 15, okay? And so this is s. We have 4 terms. We don't have any like terms to combine. All right, so this, all right, hold on. Oops. So 10s. All right, so again, we have group 1 plus group 2. All right, so what are we going to put in group 1 and what are we going to put in group 2? Well, let's try putting the first 2 together and the second 2. I'm doing that for a purpose because I want you to be able to factor out a negative. So 8st plus 12t, and then we'll put negative 10s minus 15. All right, so let's factor each group. What can we pull out? What can we factor? This is a t. What can we factor out the first group? What do they have in common? We know they have a t. And so looking at the 8 and 12, what's the greatest common factor of 8 and 12? So 4. So 4t. Good. So let's pull out 4t. And what's left? So when divide 4, 2 by each one, again, you might want to put this if you're visual. See, simplify that, we get 2s. Simplify that plus 3. So the t's cancel out. So 2s plus 3. Now, you notice inside here, everything is positive. Okay, over here, everything is negative. They're just opposites. So if you have opposites, you can pull out a negative. So when you get rid of the factor, this group, factor out a negative. Okay, so the GCF of this group here, we're going to pull out a negative 5. All right, so when I pull out negative 5, just change the plus to a minus. Minus 5, and what's left? Again, so you're dividing each one by negative 5. Negative becomes positive, so that's a 2s. Negative over negative becomes positive. 15 over 5 is 3. See, we get the same thing. All we're dealing with was the negative sign. So now, look at the big picture. What do they have in common? They have the 2s plus 3, the binomial GCF. Pull it out. 2s plus 3. What's left? 4t minus 5. This is your factorization. Okay, so that's factoring by grouping. All right, so good. All right, so they give you some practice, okay, with that, factoring by grouping, so you can do that. All right, so I'm going to start with the factoring trinomial 1, but I'm going to do that in a different video. Okay.